Hello. We will try to also show a demo in this case of the MemGuard environment running in Linux. On top of Z-board running Linux kernel 3.17, we developed an environment where we can run two videos, as we saw in the previous presentation. We can run one video on one particular processor. In this case, it's -C0, so it means processor. This runs on core 0 of the Z-board, and then we will run also another one on C1, and in this case this particular video, which is identical to the previous, will run in processor 1 of the Z-board. The Z-board has two A9 processors. Now we will be able to go to the environment of the MemGuard, install our module of the extended MemGuard in this case, and try to see first of all that the module is loaded. In this case, we had a little problem, as you will see in the video, and this had to do with the date. Because the Z-board doesn't keep the date, we had to update the date and then reinsert the module. So, as you can see, the date for the Z-board shows 1970, Linux starting date, and now we just copy the correct date in order to be able to insert the module. And we have the same problem if we want to recompile things in the kernel. We always have to be careful about the date. In this case, we have removed already the module, so we just insert the MemGuard module. And now you can see that the module is inserted correctly. You can see the parameters of the module as it is initialized to cores, qmin, a number of qmin, to particular number for the bandwidth and period and so on. A period is set to 1 millisecond, and you can see the videos running, collecting information on the bit rate. If we run the message, we can see that the bandwidth is fairly allocated between the two cores. One receives 8, one 16, and this fluctuates between 9 and 17 and so on. This depends on the other processes that run on these cores. So we cannot set it up exactly, but we take into account that this is a very light process of a video, actually an MPEG-2 video. So we don't really do very heavy computation on the memory. In this case, we changed the max bandwidth to just 40 because it was very, very large. And we can do the message just checking that we limited the bandwidth. You can see that the bandwidth stays the same because 40 is within the range that we can have. And actually now with MemGuard, we have a fair allocation between the two, 14 and 18 and things like this. So now, however, we set it to the max bandwidth to 80, and we see that really it's regulated well between one core is at 11 to 14, the other one has 18 or something like this. Now we try to handle situations where we do something relative between the two cores. So we try to register a new value in this limit particular part of the MemGuard system, and we put a 90 at 10, which means 90% of the bandwidth will go to core 0. And we can see the changes that are 25, 27, and 5, so almost 90% is there. Also, as I said, the rates are quite small. We are able to control them. Next, we can also monitor at the same time cumulative results from the videos that are running, and we can see that one video is slowed down much more than the other one, which is progressing at the same time on the left screen. We can also do the same experiment by aligning with the same function but with a different setup. So instead of 90 and 10, we can do something like 50-50 or 10 and 90. And in this case, we will also see that this is, this case 50 and 50. We will see that the bandwidths are aligned depending on the cache misses that happen on the different cores. In this case, we have no L2 cache because we disable L2 cache because there's no L2 cache counter for the misses. So we only use L1 cache on the Z board to be able to be sure that an L1 cache miss, and you can see now the bandwidth is more fair between the two. I think we did more by changing the setup to also 10 and 90, but I think this is enough for you to see this video and understand what is MemGuard, how it's used in Linux, and what could be also the extensions that we plan, that we covered also in the other video. Thank you very much.